of the events next week. On Tuesday and Friday, we have the lunchtime talk, which will be given on Tuesday by Andrew Cooper here, who is a fellow at the center, and on Friday by Sarah Khan here, who is our postdoctoral fellow also at the center. Looking forward to these two talks, again, noon on the 11th floor at the center. Today, it's my great pleasure and honor to introduce our friend and speaker, Cailin O'Connor, who has been more than once in Pittsburgh. So it's, we're always delighted to be able to invite her here. Most of you know her work, but I will introduce her nonetheless. She is a professor in LPS at Irvine. She is also, which I didn't know, a member of the Institute for Mathematical Behavioral Science, also at Irvine.
Well, it just got closed, so no longer.
So she was. No, all right. She's does a lot of different work in biology, in social epistemology, in social and political philosophy, in philosophy of language, and so she's also an evolutionary game theorist. She has published 3 books on her own. The Misinformation Age, co-authored with Jim Weatherall, The Origins of Unfairness, with OUP, and most recently, I believe, but maybe I'm mixing the orders, Games in the Philosophy of Biology in the CUP Element series, the short series. The 3 books are all extremely good. She's published, of course, in all the best journals. Most of her recent work is in social epistemology, in the role of communication and norms in science, but also in social and political philosophy about fairness and that type of things. Our previous work, I'm not sure whether it's do work on that, was about vagueness and language, also related to communication, these kind of things. And she also done, in addition to some formal work using game theoretical tools, also some work in using experimental work on a range of topics, moral psychology, fairness, political topics, and so on and so forth. Thanks for coming back. It's really a pleasure to have you around, and we're really honored to have you here.
Well, thank you. Yes, thank you, Edouard. That was a very in-depth introduction, and I appreciate it.
Everyone should know about it.
Yeah, now you do. You know everything. Yes, I'm delighted to be here today. So the title of the talk is Why Natural Social Contracts Are Not Fair. And let's see, skip this slide. So the work I'm talking about today draws from a sort of large project and synthesizes things across this project. So I published this book that Edouard mentioned, The Origins of Unfairness, a few years ago. And it talks about models in game theory and using them to explain the emergence of unfair or unjust norms. And so the general narrative of the talk is going to draw out some things from a chunk of the book, some ongoing, continuing work in this project, some work by other people, and discuss its implications for social contract theory, and especially for our understanding of natural contracts. Okay, so let's start here. There is a robust tradition using games in game theory to model social contracts, and there are a number of different models people have used in this vein. So people have looked at the prisoner's dilemma and public goods games to think about altruistic interactions and the type of contracts that cause people to behave altruistically with each other. People have looked at the stag hunt as a model of cooperation and joint action in humans, to think about the kind of contracts that allow people to work together on joint action projects. People have looked quite a bit at the hawk-dove game as a model of ownership and coordination of ownership norms. And people have looked at bargaining games to think about contracts related to norms of fairness and justice. So today, we're going to be focusing on this last kind of game and this last sort of focus. So within this game theoretic work, one tradition models how social contracts might emerge naturally through processes of social interaction, learning, and cultural evolution. And in particular, folks like Brian Skirms have used evolutionary game theory to model this process of cultural evolution. And he argues that this kind of thinking about social contracts goes back to some very early social contract theorists like Hume and like Rousseau, who, in making arguments about social contracts, were talking about these processes where groups of people were interacting and slowly learning or agreeing to follow certain conventions to solve the sorts of social problems that explicit contracts might solve as well. So this is what people sometimes think of as natural contracts. So today, the main aim of the talk is going to be to overview work showing that, counter to some previous claims, natural social contracts shouldn't be expected to be fair or just. And throughout, what I'm going to do is discuss this evolutionary game theoretic modeling of the emergence of bargaining conventions in making this argument. So that's where we're going. Here's how we're going to get there, our roadmap. So first, I'm going to introduce the model used throughout this literature, the Nash demand game. And I'll talk about previous work using this game to show how groups evolving to play tend to learn fair behaviors in the game. Then in part 2, the evolution of unfairness, I'll describe why, despite this previous work on fairness, we should not expect fairness when we're thinking about the evolution of social contracts in this way. And basically the argument will be that these models are missing something, and that something is social categories. And once we put social categories into these models, the generic outcome tends to be unfair norms. Then in part 3, I'll talk about the role of power in unfairness and its evolution and draw out some relevant lessons for social contract theory. Good. So that's what we're going to do. So part 1, the Nash demand game and the evolution of fairness. So the Nash demand game, it's the most widely used model of bargaining in game theory. I'm going to start with like a intuitive presentation of the game. So suppose you and a friend have this delicious cherry pie. You both want as much cherry pie as you can get. You're just really, really hungry. You need to divide this pie. And what you're going to do is you're each going to make a request for some portion of this pie. And then if your requests are compatible, you each get however much you wanted. If they're incompatible, we expect that you have some sort of fight. There's a disagreement and it's an unpleasant outcome for you. So you can think about for a second what you might demand of the pie. We'll return to that. But first I want to pull out the basics of the strategic scenario that we're looking at here. So this isn't a literal model of people making simultaneous demands for pie. The basics are that you have 2 individuals. There's some kind of resource. That resource can be divided between them. There are multiple different ways to do it, which are more or less preferable to the 2 individuals. But if they're too jointly aggressive, they won't be able to successfully divide the resource. So that's actually a fairly common strategic situation that people find themselves in, which is part of why this model has been so widely used. So it's been used to model international trade agreements and salary negotiations and bargaining over labor in the household, for example. All right, so what happens? What do we expect to happen in this kind of scenario? So in answering that question, we start with the Nash equilibria of the game. So this is the central solution concept in game theory. And these are pairs of strategies where when individuals are using these strategies, no one can switch what they're doing and improve their payoff. And the idea is that if there's no incentive for anyone to do something else, you expect those strategy pairings to be stable in some sense. So this game actually has an infinity of Nash equilibria, and these are every pair of strategies that perfectly divide the resource. So if I ask for 70 and my partner asks for 30, that's one. Or if I ask for 8% and my partner 92%, for a second I was like 98, no, not 92, that's another one. So these are the Nash equilibria because basically when you're playing this game, there's 2 ways you could change strategies. You could ask for more or you could ask for less. And when you're perfectly dividing the pie, If you ask for more, you over-demand the resource and you get this bad conflict outcome. If you ask for less, you just get less. So those are the stable outcomes we expect. So that's our first prediction, that actors are going to perfectly divide resources. But of course, there are a lot of ways they can do that and different ones that are preferable to each actor. Now, despite this surfeit of equilibria in the model, there are some empirical results that show that people tend to arrive at the 50-50 split. So if you put people in a lab and have them play this game, they almost exclusively request half the resource. And in addition, most cultures have stated norms related to fairness supporting equal splits. So if you ask people, absent any sort of context, how people ought to divide some kind of resource like this, a windfall resource, they'll say, well, they ought to each take half. So although there are so many equilibria of this game, the evidence suggests that there's something special about the fair split, the 50-50 split. And this creates an explanatory demand, which is what is special about the fair split? So in philosophy, Brian Skirms, and then in economics, and Jason Alexander, in economics, Peyton Young, and some others, have taken up that explanatory demand. And to do so, they turned to these evolutionary models. So ones that look at cultural evolution to say why one equilibrium might emerge out of a set of possibilities. And for Brian Skirms, this was part of his larger project modeling the evolution or emergence of natural social contracts. So what's the difference between the sorts of models they were looking at and ones that predict these many infinite equilibria? So game theoretic models use rationality assumptions to predict individual behavior in strategic scenarios. So the idea is that the players are rational, they want as much pie as they can get, they think about how they could get the most pie, and then they make a choice consistent with that rational process. Whereas in evolutionary game theoretic models, instead the assumption is you have a group or a population where individuals are repeatedly playing a game, and then based on their experiences, they evolve over time via learning, or if you're looking at a biological model, natural selection. So strategies change slowly over time as the result of interaction. All right, so the evolutionary models that these folks looked at used a simplified version of the Nash demand game. And here's a representation of it here. So there are two players. We have player 1 and player 2. They can now each make one of 3 demands for the resource: low, medium, or high, low, medium, or high. And we'll say that the resource has a value of 10, and these demands are for 4, 5, or 6 of that resource of 10. But the details of the number here, they don't really matter. It's just as long as they have sort of the right relationship to each other. And then these entries show what they get for these various demands. So if they both demand low, well, 4 plus 4 is less than 10, so they each get what they ask for. If player 1 asks for high and player 2 low, 6 and 4 are again compatible, so they get what they wanted. If they make high demands together, they've over demanded the resource, and we say they get 0. Again, it doesn't exactly matter that it's 0 as long as it's a low kind of bad outcome. All right, so this simplified game now has 3 equilibria. These are again the places where the actors perfectly divide the resource. So one gets high and the other low, they both get medium, or the first one gets low and the other high. And again, at these equilibria, if anyone asks for more, they over demand, and if they ask for less, they just get less. And so there's a kind of stability to these pairings. And notice that again, we sort of replicated the strategic scenario in the bigger model. There's multiple outcomes, multiple ways to divide a resource, and the players have different preferences over how that gets divided. So this is the base model. Then what Skirms and Young and Alexander and some others did is looked at models where you had a group of individuals, they're playing this game, they're learning over time, maybe they imitate group members who are successful. Maybe they repeat behaviors that worked well, and then they see, okay, what happens? Where does the group end up? So to greatly summarize, what they find is that most often in these models, across a number of different modeling assumptions, fairness, or a group of everyone demanding medium, tends to evolve with high likelihood. And then sometimes you also get outcomes that are sometimes called fractious, where you have some high and some low demanders. But fairness kind of pops out of the model. So why would that be? So I'm going to give a hand-wavy explanation. Imagine a population where everyone here is using the fair demand. So they all demand medium. My population is tiny humans. This is a special population because anytime two individuals from this population bargain, they're going to perfectly divide the resource. And this is the only population where that will be true. There's a sort of perfect symmetry in the way every individual is asking for half. And so there's an efficiency in what happens when this group is dividing resources. That's not true for any other population distribution. So if we have some lows or some highs or some both, sometimes individuals meet who over-demand the resource, sometimes individuals meet who under-demand the resource. And the basic explanation, a little hand-wavy, is that evolution is sensitive to this kind of efficiency. So the general project takes these models and this result to help explain the prevalence of fair bargaining norms, and then to support accounts of social contract theory where justice emerges naturally. Okay, you have human groups where people are bargaining and they're interacting, they just learn to treat each other justly, is the idea. And then further work in this project has outlined conditions where fairness isn't just likely, but it's certain to emerge. So they've looked at things like, suppose the same individuals tend to repeatedly interact with each other, or suppose individuals can communicate with each other. In those conditions, fairness is even more likely. Those conditions are relevant to human groups. This helps explain the prevalence of fairness norms. So that's how the argument from that literature goes. Good. With that, let's move on and talk about the evolution of unfairness. So several influential works have criticized social contract theory on the grounds that it fails to account for the prevalence of unfairness and oppression. So first, Carol Pateman's The Sexual Contract considers how patriarchy suffuses rules of justice across societies. And then later, Charles Mills's The Racial Contract considered the way race has been used to organize widespread oppression and inequity. So in his book, he points out that although social contract theory talks about a big game for equity for all men, people of color are often not included in the social rules of justice. So the kinds of phenomenon that Pateman and Mills are talking about are widely recognized. So across the social sciences, it's widely documented that some types of people get more, other types of people get less. There is unfairness in the world. And this kind of phenomenon arguably introduces another explanatory demand, which is why, despite this ubiquity of fair demands in bargaining models, you see so much inequity in the world. So that's what we turn towards explaining now. All right, and looking at these two books gives us a hint at where we want to focus here. So notably, both accounts are looking at unfairness related to social categories. Social categories are categories that are widely recognized within a society where there's a lot of intersubjective agreement about who is part of what category, and where members of that society use categories to guide their behavior towards others. So even in the same strategic scenario, someone might behave differently towards people who they perceive to be in two different social categories. Sociologists sometimes talk about primary social categories as the ones that are most important for shaping interpersonal behavior. So the ones that aren't just meaningful in one context, like TA and student, for example, but are meaningful across many life contexts. And sociologists have argued that across societies, gender and age almost always constitute primary social categories. And then the other common ones you see are race, class, caste, and a religious affiliation as well. So what we're going to do is add social categories to evolutionary bargaining models. Now, it's typical that when you're looking at evolutionary models, you have a single unitary group of individuals who are interacting. It's your, evolving population. So what we're going to add to that to capture the evolution of behavior when we have social categories is what we sometimes call types or tags. So we're going to want a model that has multiple types or individuals with different tags. One early influential model along these lines came from Axtell, Epstein, and Young, who developed what's sometimes called the emergence of classes model. And what they look at is a model where actors are evolving to play the Nash demand game. So same kind of models we were talking about before, but instead of there being one recognizable type of actor, there are two recognizable types of actors, or actors with two different tags. So now we might say we have a population with little Humes and also with little Rousseaus. So when you evolve this type of model, the same way as the last ones, but with the addition of tags, you actually get an entirely new set of stable outcomes or equilibria. In the last models, those stable outcomes were the fair and the fractious outcomes. Now what we find is that within groups, you get those same outcomes again. So you get fairness or fractiousness within groups because each group is kind of like a single population. But between the groups, you can get any of these three sort of base equilibria, but now as a between group norm. So you can get one group demanding high and the other demands low when they meet, both groups making medium demands of each other, or the first group demanding low and the other high. And notably, two of these outcomes are a sort of thin representation of what we might think of as unfair or discriminatory conventions. So at the two outcomes where one group demands high, one group is getting more at the direct expense of the other group. And there isn't some justificatory reason, it's just because these tags exist in the model. All right, so here's what that kind of outcome might look like. So the Humes are fair with the Humes, the Rousseaus are fair with the Rousseaus, but when a Rousseau and a Hume meets, the Hume always requests high and the Rousseau low. And because you have two types now, notice that you can have high and low demands occurring in this population, and it's still efficient. Every time two individuals meet, they perfectly divide the resource. In the same way that we had for just the fair population with a single, just the fair demand with a single population. So the presence of types is allowing actors to coordinate on an unequal split in a way that they couldn't do before. So to get further at this, in models with one group, that symmetric fair demand is special. But when you have tags, they create a symmetry breaker. They allow for these conditional rules like Humes get more and Rousseaus get less. And now those can be efficient, and actors can coordinate their unfair expectations using social categories. So Axtell, Epstein, and Young in their work find that these kinds of discriminatory conventions emerge robustly in models with social categories. And much subsequent work, including in the book, confirms that this is a robust, widespread result. All right, so one thing I've sort of pulled out in some of my work is the preconditions needed in these models to get unfairness, and argue that they're fairly minimal. So the things you need to ground unfairness is you need social categories. So you need some kind of recognizable tag. You need conditioned behavior. So you need people to condition their bargaining demands on the basis of that tag. And then you need learning. And so I've argued, well, these are fairly ubiquitous in human groups, kind of hard to eliminate. On the basis of this, we can think something like, whenever you have social categories, well, inequity isn't hard to generate. Thus, we might say models of natural contracts don't actually generically predict fairness. Unfairness is also possible. And part of what I'll argue in the next section is it's not just possible, but probably the more generic prediction from this kind of model, the thing you expect more of the time. All right, so let's talk about extending these models to think about situations where the groups are not sort of perfectly symmetric in any way, but where one group might have a power difference to the other. There might be power asymmetries, and talk about how that would impact our expectations for the evolution of bargaining. So in a paper, Power, Bargaining, and Collaboration, Justin Brunner, pictured here, and I showed how powerful groups in this kind of model tend to evolve to get more. And then in follow-up work with Travis Lacroix over here, we extended this to situations with heterogeneous groups. So groups where you could have individuals in both groups, an average power difference between them, but differences within each group and how much power the different individuals have. All right, so to do that, we needed to add power to our models. So power obviously is not a simple concept. There are many things that power can mean, many things that philosophers have talked about that power can mean. One very common disambiguation in the philosophical literature on power is between power to versus power over, where power to tracks something like an individual's abilities, given their resources, personal and otherwise, to get what they want and act how they want in the world. And power over tracks something like an individual's abilities to make others behave the way they want them to. So what we did in our paper, given this kind of, complexity of power, is just looked at a number of different ways of capturing or operationalizing it. So what I'm going to do here is talk about just one of those ways, and one that's kind of nice in that it fits with the historical literature on power in the Nash command game, and also can track both senses of power, power to and power over. So this operationalization of power involves the two actors having different payoffs for when bargaining fails. So this is sometimes called the disagreement point or the threat point. Now, this sense of power in the model goes back to John Nash's work on bargaining in the 1950s. And the idea is, okay, if when a bargain fails, an actor is in a better fallback position, then the bargain matters less to them, and arguably they should have more sway over the bargain than their partner, for whom the bargain is more crucial. So these differences in fallback position could arise from different things. So it could arise because of background facts about the actors. So one is in a better economic or political or social position, for example. That could create a better fallback position. Or, and this was something that Nash introduced under the idea of a threat point, it could be that the actors threaten each other. If this bargain doesn't work, here's what I'm going to do to you. And in that case, the fallback positions could arise from the power the actors have to lower each other's payoffs if the bargain doesn't work out. So those are the two senses where this can correspond to power to, my personal empowerment to act as I like, versus power over my ability to decrease my partner's payoff if they don't do what I want them to do. All right, good. So the main finding in these papers is that this sort of power tends to mean that a group will get an economic advantage in bargaining conventions. So having this kind of power will tend to mean that a group demands high more often. So here is a figure. On the x-axis, what we're doing is increasing the disagreement point for one group. So we keep one group's disagreement point the same, make one's higher and higher. So they become more powerful in this sense. And then this shows how often across different simulations, so we might simulate it several thousand times, these three possible endpoints arise. The powerful group gets more, they make medium demands, or the powerful group gets less. And as that power increases of that group, fairness becomes less and less likely. The powerful group stops ever receiving the low demand, and it becomes more and more likely that the powerful group ends up receiving the high demand at these conventions of bargaining. So why does that happen? It happens because the powerful group in these models has relatively little incentive to learn the low demand. So they don't get a significant advantage for doing so, because if they have a fallback position of 3.6 and the low demand is 4, there isn't much sort of learning pressure for them to move towards those. So in the models, they tend to learn the high demands faster, and the low power group, the low demands faster, and then that tends to push them to these unfair outcomes. That's what I just said. And we find this generally across a number of different varieties of these models in both papers. And notably, this pattern can emerge even if you just add a few powerful individuals to one group. So you could have a situation where, say, these groups are representing gender. Women on average might be less empowered than men in a society. So the entire group can end up being disadvantaged by bargaining norms, even the individual women who are themselves highly empowered, who have a lot of money or a lot of social status. So this is a model where we started with 2 identical groups, and then we added one powerful individual to one of them. So to one of the groups, we added just one individual who had a high disagreement point. And you can see in this version of the model, the qualitative outcomes are very similar to the other model I described. So here we're increasing the disagreement point of just that one individual, making them more powerful, and then asking which of these 3 conventions the entire group settle on. And again, we find that fairness decreases and the powerful group becomes, the group with one powerful individual, all of them become more likely to end up demanding high as a result of that one individual's empowerment. All right. So in the Origins of Unfairness book, I extended this thinking about power to consider how power might compound and reproduce itself in these sorts of scenarios. And in my models, what I assumed was, okay, if a group ends up demanding high in one set of interactions, that's going to raise their disagreement point in future interactions. The idea being something like, if they're demanding high, they're getting an economic advantage, and that tends to translate to a better fallback position for further bargaining. And what I found is, if you looked at this kind of process where compounding can happen, even if you start groups exactly symmetrically, one of them always becomes systematically empowered. So one of them develops a high disagreement point, one develops a low disagreement point, and the one with the high disagreement point tends to win these evolutionary struggles to end up getting high again and again. So that happens even from symmetric points, but I also found in these models that small initial differences matter. So if there was some kind of initial power difference, one group had a slightly higher disagreement point, they tended to be the ones who ended up empowered compared to the other one. All right. So in follow-up work, Justin Bruner and Liam Bright and I didn't make this image of Liam. He made that himself and put it on the internet, so his own mistake. We also use this framework to think about intersectional disadvantage. So we asked, do people with disadvantaged identities that intersect expect particularly acute disadvantage as a result? So that's a sort of key thesis of intersectionality theory, that different types of disadvantaged identities compound or create non-additive disadvantage. So we built models where the actors could have multiple tags representing maybe race and gender, and where they could bargain in different arenas, and where these tags could be associated with advantage or disadvantage with respect to power. And we found that this kind of non-additive disadvantage did occur in these evolutionary models. So sometimes we saw, fairly often we saw effects where people who were at the intersection of two disadvantaged identities did significantly worse than either of their identities would predict as a result of that. And these models were like, they got phenomenally complicated very quickly. And so we ended up sort of using them more as like a proof of purpose for this and less as, like a real representation of the complexities of intersectional disadvantage. But if people want, we can talk more about that. All right, so kind of general takeaway here. Power asymmetries between groups tend to promote unfairness. They tend to make unfairness more likely. Now, I think when we're thinking about real world groups, symmetry is extremely rare. You almost always are going to have asymmetries between any meaningful groups. And I also argue that in the initial absence of power asymmetries, they tend to emerge. So given this, and given that asymmetries tend to be the rule, I think that these models looking at power support the picture where unfair contracts are what you expect to emerge naturally, rather than fair contracts. All right, so you might respond to this. To get unfair contracts emerging in these models, you're always assuming that social categories are in place in the first place. But that might mean that in cases where social categories aren't salient, or if we could get rid of them, we'd return to a situation where fairness is the expected outcome. So we'd return to the kind of model that Skirms and Alexander and Young were looking at. But these models also illustrate how social categories can and do tend to emerge in these scenarios endogenously. So how when you have these sorts of bargaining situations and there are potential tags that could be used as a locus for unfairness, those tags tend to get used. So that is what I will talk about now. So in this nice paper, Fairness and Signaling in Bargaining Games, Popa, Muhlenberg, and Wyatt look at how the information content in various tags influences whether and how unfairness emerges. And in general, they show how tags in these sorts of models have to carry enough information about group membership in order to allow inequity. So there are a number of ways tags could fail to carry information about group membership. They could be flexible, they could be unclear. I'll talk about what that means in the model in a second. And if they are, unfairness tends to be less likely and less stable. So we could contrast a picture like this, which is the type of model we've been talking about, with one like this, where now we have Humes and Humes stars. And the way we'd build this into the model is to say, well, these tags are unclear or hard to recognize. And so we'd say there's some probability that someone correctly identifies another individual's tag, and then some probability that they mistake that individual for a member of another social category. So I might treat someone as an in-group member when in fact they're an out-group member, or vice versa, because the tags are less clear. Or we could look at models like this, where individuals can also choose to update their tags. So a Hume could switch to look like a Rousseau. So that would be an example where the tags are more flexible or less heritable, depending on what you're thinking about. So general takeaway from their paper, tags that are less flexible, that are more heritable, that are more observable tend to support unfair bargaining rules. So just to give an example, if you're at an outcome where one group's getting more and one group's getting less, but individuals have the option to switch tags, the ones getting low might learn to switch tags and then not get low anymore. And that could potentially destabilize this unfair equilibrium. Okay, so Liam Wright, and then Olufemi Taiwo, who's here, and Nathan Gabriel, who's here, and I, in a paper, use similar models to the Popa et al. Models to think about how race in particular can underpin unfair contracts. So the paper argues, well, race, especially the way it's been constructed in some societies, tends to be difficult to change, tends to be heritable, and tends to be easy to identify. And then we argue that these features explain why race, instead of some other type of social category, has so often been chosen in evolutionary time as a locus of oppression. So why is this the category that we look at and use for oppression versus other types of categories? And then we also think that this argument helps explain why race as a cultural construct has the particular features it does. So why we have the social rules we do about race. So part of the idea is that, especially when you have powerful groups and there's some kind of development of an unequal system, some actors are going to have to get more and others are going to have to get less. This creates a need for something to stabilize that inequity. Why should some people get less? And why would that be race? Well, it has the right kind of properties to create that stability, is the argument. So we looked at a number of models in this paper. One we looked at considers what sorts of tags a powerful group would learn to attend to. So in this model, we assume one group has more power and one group has less. And we assume that there are multiple tags available to condition behavior on. And in particular, for the less powerful group, there are some tags that are more reliable and others less reliable. So some tags that always pick out members of that group, other tags that are easier to mess up, that you might get it wrong. And then we let the powerful group evolve to either pay attention to reliable or unreliable tags, and we find that they tend to evolve to pay attention to the reliable ones. So the reliable tag emerges endogenously as something to underpin inequity. Here's a figure showing these results. So on the x-axis here, we're making that like powerless group tag more and more unreliable. So we've got a reliable tag and an unreliable one. We make the unreliable one worse and worse. And what we find is that the powerful group focuses on it less and less. They pay more and more attention to the one that allows them to pick out the powerless group. And that's what this is showing. Their probability of looking at that unreliable tag goes down. And notably, that effect is stronger the greater the power difference. So these traces track different amounts of power for the powerful group. The more powerful they are, the more they attend to the tag that allows them to create an inequitable system. Because the idea is that powerful groups in these evolutionary scenarios, they're more likely to be heading towards an outcome where they can get high. But for that to happen, they have to pay attention to the reliable tag. And so those things co-evolve in these models. So takeaway, even in the absence of meaningful social tags, cultural evolutionary pressures can lead to the emergence of the sorts of categories that can ground inequitable contracts. And I think that again sort of supports this picture where unfairness is easy to get. It should generally be the rule in groups with social categories. One thing I argue is that when thinking about countering unfairness, then it's not something we should expect to do and be done with, but rather, because unfairness is emerging endogenously, equity is less an achievable state and more a process, an ongoing process. So I will wrap up by summarizing. Because of the presence of social categories, we shouldn't expect emergent natural contracts to be fair or just. This helps square earlier evolutionary work with the kind of critiques we see from folks like Mills and Pateman of social contract theory. Power asymmetries between groups tend to increase the probability that you get unfairness. Power asymmetries tend to emerge, and social categories can culturally evolve that underpin unfair systems themselves. With that, I will say thank you. Let me finish.
All right, thank you for these great talks. We've got plenty of time for questions, and after there will be a reception. Sandy, why don't you start?